Yes, I think it's live. So, welcome, Dr. Thomas, and welcome everyone to this session on the project that
Yes, I think it's
Dr.
live. So,
Thomas is
welcome.
running. And today our talk will be basically on the initiatives that SenseBox is taking. May I introduce Dr. Thomas briefly? So, Dr. Thomas is with the University of Munster, right?
Right.
And he's also founder and head of research and student laboratory at GI at School, and the head of this SenseBox project. So he's expert in learning with geotechnologies. He is also interested in human-computer interaction research and jointly with citizen science. So I will be very happy to know about more on citizen science, and I think it's interesting also for everybody here. And he also developing some products with SenseBox, if I'm correct. So welcome, Dr. Thomas, and you can start your talk with what you are doing with SenseBox, and the floor is yours.
Thanks a lot, Francis. Give me just a second to share my screen. So.
Thomas joined.
So I hope it works. Yeah, it seems like great, perfect. Thanks a lot for the short introduction, Francis. Yeah, welcome from my side. Welcome from Münster. Münster is in northwestern part of Germany, more or less close to the Dutch border, where I'm situated at currently. And well, today's talk, my talk on the SenseBox project, the SenseBox itself, and then with some focus on sensors in general, IoT, and the broader topics of citizen science and digital learning or digital education, however you would like to call it. My background is in geoinformatics, so I'm a postdoctoral researcher at the Institute for Geoinformatics at the University of Münster. The University of Münster is one of the largest universities in Germany, I think 5th largest, something like that. And we have also the oldest institute in the geoinformatics context in Münster here in Germany. Also one of the largest institutes. And I studied here, so I did my master's degree a few years back, and I also did my PhD here at the University of Münster in geoinformatics. And the topic was, as Francis said, learning with geotechnology. So my interests pretty early on were in education and how to make learning better with the help of the technologies we work on in our institute, in our science. And you see here on the left side on the title slide 3 logos. So the first is the one from the university, from the institute where my major head is from. But a few years back, 3 years back, I co-founded a spin-off startup that we have created out of the work in our lab, in our GI at School lab at the institute. So the spin-off is called Redo. And there, Redo is currently the producer of the SenseBox you will get to know in a few minutes. And we also do plenty of other projects at Redo related to digital education, to citizen science, and our technologies. And most recently, so this is like only a month back, I founded another startup called OpenSenseLab, which is a non-profit that will hold our platform, our data platform, OpenStreetMap, that we will get to know also in a few minutes. But this is enough of the few hats I can change between, and let's start with my opening here. Yeah, so I just found this slide here, or I found this picture on the IBM website, and we could also switch to other major companies, Cisco or whatever you would like to go for. And this is something that we have seen since a few years back. Data as the new oil, maybe something that many people have coined in the last years, but also especially data on our environment, or here, for example, from IBM, weather data. Weather means business, weather data as a driver for digital innovation. So data on the weather, but also on other environmental aspects gets more and more important in many senses. So one already can think of knowing about weather will help huge server farms to manage the cooling down of servers and things like that. That will really reduce costs, but also some issues for other companies, for agriculture, for other things. So data on the weather forecast is something that is getting better the more data we have, of course. Yeah, and these things are of high interest for many people, and also for many businesses, as we see here in this example. But data, well, we need a lot of data to take specific decisions, and this is sometimes a problem. And I have some examples here. So starting with this small map of Germany with a few cities or places you probably have not come across with. Maybe Munich and Dortmund is pretty well known, especially from soccer, but probably the rest not very much. So these are the 13 places in Germany that have official stations measuring UV light. Yeah, by the authorities, by the ministry, one of the ministries taking care of that. Yeah, and only these 13 stations deliver data on UV intensity in Germany, and everything we hear from for example, in the news now in the summer that UV intensity is high in this place or in this place, and we should take care and use sunscreen or whatever, is coming from these 13 stations, and this. Places in between the big holes are, of course, mathematically calculated, but still there are plenty of errors in this data. And we would need really much more data on UV intensity. Another example from Germany as well, this pixel-like map, I got it like that a few minutes ago. So it's a map from the official German weather service. And the official German weather service has I don't know, a few hundred of weather stations following the standards of the WMO, the World Meteorological Organization. And here you also probably don't know any of these places, but it's the region we are from, because in the middle, in the biggest hole here between these places is Münster. Yeah. So this is the place where I am right now. And you see this hole without this little blue triangles has a more or less diameter of 60 kilometers. So here, especially in the topic of weather, temperature, and things like that, this is already a distance where microclimates can happen, especially in city. And Münster is not a very small city; it has 300,000 inhabitants. So the differences might be of a few degrees, for example, in terms of the temperature. Yeah. So we have a weather station, official weather station at the airport. In the north and 30 kilometers to the south in some small cities, but not in Münster. And this is due to the high standards the platforms need. So there was one like 50 years back, but then new buildings came around and were built, and this weather station did not meet the high standards of the WMO. Another slide I like to show in this context, which is already a tweet a few years back, but it's a real tweet. It's an original tweet of this guy here. The concept of global warming was created by and for the Chinese in order to make US. So this is another problem. One problem is the data problem. We are somewhat in miss of the data. We miss data of a few things in a few places. Another problem is that there are people also posting these things and making other people believe these strange things. And I think we need to work on both problems. We need to work on one problem to get more data, and the other problem to trust in data and trust in science. And this is something that we care about here in this project. I would like to talk about. One example from my personal experience, this is a picture from Sao Paulo I took, I think, three years back. In Sao Paulo, it's one of the largest cities in South America, and I think it's like 15 million inhabitants in the whole area, with maybe as many cars as that. and it's traffic all around the city all the time. Yeah, so I spent there a few weeks, and I was really a lot of time in the car or in some public transport because it's stuck in traffic all the time. And then you see this displays I have here on this picture showing time, temperature, and you see this little. It's a green block. It's a green light on this display, and it says Arboa, which means good air. And it is also a display showing the quality of the air. And I was for a few weeks in the city, and I've seen like hundreds of these displays, and all the time, at any time of the day, they've shown good air. Yeah. It was somewhat strange. You are standing in the traffic jam for hours, and you look at this good air display. So I was investigating that a little bit further, and this is something really interesting. Brazil has one of the best open data policies in the world. So all data is open. You can find all kinds of data from all satellites that Brazilian government is having, using, or all kinds of weather stations or whatever. So you can find all the data. It's not like in Germany where it's much more difficult. But yeah, you can find the data. And I came across this map here of the metropolitan region of Sao Paulo, the state of Sao Paulo, displaying the places where the weather stations, the air quality measurement stations are situated in the city. So there are like 20 something of these stations around. And you can get all the raw data. But what you also see, and I followed this site for a few months, and it was green all the time. Yeah? I found once a yellow dot for moderate air somewhere in the city, yeah? but it's really strange. And then if you like to check, and if you speak some Portuguese, then it's possible to go in deeper and find out about this index, the quality index, what is good air, in fact. Yeah? And then if you really dig deeper in the mathematical functions that how this index is created, you will find out that it's real. Yeah, the air is good all the time, because it needs to be good due to the functions that are used. Yeah, so if somebody can invent an index, and if you can invent an index, and you want that every display says it's good air all the time, you can go this way as well.
Sorry, a quick question, Thomas. Did
Yes.
you notice, or did you find what kind of sensors they were using to measure what type of quality of the air here?
Yes, so it's a mix of sensors. It's a mix of so there's fine dust, nitrogen, NOx is involved, carbon dioxide is involved. So they have really high quality sensors. It's high quality air quality stations, measurement stations with plenty of high quality sensors. So the sensors are good. And the data of each sensor is good, and it's correct raw data as far as you can see. But the index is made in a way that independent of anything, that the display is showing good air, which is a problem, of course. And you need some experience. So the data is open, and you need some experience to understand that. And this is something that is missing. And this is something where citizens somewhat are fooled. I think people living there or people visiting the city are somewhat fooled. And on the one hand, it can't be good air because you can smell it. You breathe this air in this traffic. But well, you see the displays, and it makes you feel a bit more comfortable, maybe.
Yes.
And this is an issue, and this is something also we would like to change, something to give more power, to give more understanding to the people somehow. So this speaking of sensors, and I also seen in this course here that you were speaking about wireless sensor networks and things like that. So I just wanted to open up also a discussion on or starting with some technological issues, how these kind of sensors, mainly used by the authorities, as here in Sao Paulo, how they manage to transfer the data. Yeah, and generally, there are three approaches for geosensor networks, and the one I was speaking about right now is the one from the authorities. And the question was correct here. So, what kind of sensors? Yeah, it's high quality sensors. It's of high costs usually. They use high standards, as the WMO, the World Meteorological Organization, OGC standards. I'm coming back to that in a few seconds. And due to the high costs of each station, there are only low numbers of stations. So in such a huge city, only 20 something sensors, or for example, in whole Germany, only 13 sensors for UV intensity, only 200 weather stations in whole Germany. So it's low numbers. Yeah. Then you have the approach of businesses, yeah, that usually also can do it for authorities, yeah, as we have seen in the IBM example, or Cisco, whoever right now is offering services in the context of smart cities. They usually also have high costs, of course. The businesses need to make business, so they have high costs. And then there is the third approach, which we'll come back to later. It's the citizen approach. Yeah, there is a small typo. Sorry for that. Usually with citizens, we need to work with low cost. Yeah, if citizens take care of the sensors, if the citizens take care of the measurement, and if citizen science as an approach is being used, well, this is another way, and I'm going to talk about that in a few minutes. Starting with the authorities and the sensors that are being used, and the standards, high standards are being used, we often hear from OGC. The Open Geospatial Consortium is somewhat a consortium for geospatial data standards, and something from ISO maybe. It's a parallel organization that takes care of everything related to geo, basically. And they have the so-called Sensor Web Enablement Initiative, the SWE initiative that works on the sensor web enablement and the use of sensor data, mainly through in authority use. And also coming, or the OGC things usually originally the background here is also in the military, but the standards are of high quality and are being used in a broad way as well. For example, in the European Union, the INSPIRE initiative is closely related to that. And so we have different agencies, for example, the environmental agency, regional ones, or the European environmental agency that takes care of any kind of weather station, or of, for example, air quality stations. They use so-called sensor observation services, and some kind of network is leading the data towards some clients. Yeah, towards such a website we have seen from Sao Paulo, such a web client that shows the data on a map, or it might be a GIS where the data is being pushed to do some analysis or whatever. Yeah, but on the servers, there's kind of a lot of sensor observation service. And this middle tier, this network tier, brings in the standard itself, which is when we speak about environmental information, environmental data, it's the standard called, and it's a mixed OGC ISO standard called Observations and Measurements. Yeah. So it's a very general standard that has some also specializations. For example, you see on the left side here, a specialization of the observations and measurements for water. Yeah, it's water ML. Yeah, so there are special fields in different, let's say, environmental fields that can be applied. And this ISO standard, ISO OGC standard, observations and measurements, it speaks about what is the feature of interest, what is the sensor, what is the observed property, results, phenomenon time, and so on. If you check on the standard, if you just Google that, observations and measurements OGC, it's really a huge document. It has some 100 pages to describe the way, it describes a way how to describe observations and measurements. Yeah, so it's really a huge document, and this is something that we in geoinformatics grow up with. Yeah, so we learn these things, we learn how to be conform to such a standard, because it's how, for example, authorities want the data, how the INSPIRE initiative in the European Union wants to be the data represented on all levels, from the EU level to the country level, to the state level, to the city level, or whatever. Yeah, so you need this understanding as well. And this is an example of some code snippets and a lot of XML things describing one measurement. Yeah. And well, there is some kind of this communication between the sensor observation service on the server and the client. Yeah, so there's a lot of communication going on here. It asks the client for the capabilities. Sorry, the client asks the service for the capabilities. What can you offer me? And it answers, yeah, here you go. And then it asks for the sensor. What kind of sensor is this? And it receives back an information on the sensor and sensor modeling language, and get the observation from the sensor at this time, and you get this observation and measurement. So it's also a lot of communication going on here. So, and this is already a little bit old school, yeah. So the sensor observation service that is applied in all kinds of things is not yet in this way we speak about in IoT, in the IoT world currently. Yeah? This is a little bit in advance, this client server model here. For in IoT times, and now we are like, let's say around 5 years back, they came up with a so-called Sensor Things API. It's another standard from the OGC, which is more complementary to the ideas of the Internet of Things. Yeah, it's a little bit simplified than this very complex approach. It's based on web technologies that you get around in the IoT world. So REST interfaces, JSON for describing for JSON packages to describe the measurements, for example, and so on. So it's much simpler. But I'm also not going very deeper into that. If you check on the Sensor Things API, you will come across this a diagram as well. What is the thing? What is the data? How the data stream is processed? What the sensor brings in, and so on. So still, I just want to show with this diagram that still it's somewhat complicated, and still something, and that's where I want to go. Where if we want to work really with masses of sensors organized by citizens, it seems still to be too complex, so everybody would understand that. Yeah, you still need to be a professional to understand that. So what about the systems? That's the question. Yeah. So we have a lot of things, a lot of complex things, and they somehow it's too complex to understand such a index as in the Brazil example. It's too complex to understand the standards in some way. And also, if we think about data, if accessibility to data, there might be also things that are too complex to access the data. We have now in Germany things changed a little bit towards the open data. So that we have open data laws for some authorities, and since 3 years, I think since 2018, the German Weather Service I was speaking about needs to follow an open data law, and all data acquired by the German Weather Service needs to be open. And you would think, oh wow, that's a great law. Now everybody can check the some 100 weather stations and check back the data from last year and whatever, and to understand maybe and to understand what climate change makes in my community. Yeah? And then if you check for the data, here you go. It's a screenshot I made today. Opendata.dwd Deutscher Wetterdienst. Yeah, it's an FTP server. Yeah, it's an FTP server, and if you dig deeper in the folders there, so it's tons of folders of whatever. So you would think they need to do that. They need to do open data. They need to open the data. Everybody can access the data, but nobody would understand. Yeah. What kind of data is there? And what is that? Yeah, so you would expect to have maybe a map. Yeah? You would expect to have a map to click on a weather station and then see the data of today, see the data of yesterday, of the last year, of whatever. But they just don't do it. Yeah? They don't have to. They have to. The law says you need to open the data, and they did it. Yeah? Everybody can access it, but nobody has the ability, or a few people only have abilities to understand even how to get the data. So this is another problem. Yeah. Yeah, but what might be the solution? The solution, and we mentioned that a few times, or it might be a solution, but it's an approach.
Thomas, there could be a couple of questions. I think I missed one of the interesting question about also from your previous slide, where you were showing communications between clients and this server. So, I mean, what type of APIs there are, and what are the standards in these communications, also in terms of protocols and so on. So maybe you could elaborate a bit about. You also mentioned things
The Sensor Things API or the Sensor Observation Service. So you know, the Sensor Things API uses REST interface, yeah, and JSON packages that are being transferred to be as good as the Sensor Observation Service. And the Sensor Observation Service is itself, it's a web standard. Yeah, it's a web standard using HTTP requests, and it's more or less old school. Yeah, so this is nothing. It's not rocket science in this thing, but it's really a complex standard. So if you want to know more exact things about the OGC Sensor Observation Service or observations and measurements, just go on the OGC website and you see everything on the specifications here. Yeah, I would.
And then also there was a question about Elasticsearch. So did you use, or on this project, did they use Elasticsearch? That would be good for indexing, data indexing.
On which project do you mean? On Sensor Things or?
On the project that you were mentioning before, is it the project in Germany or it's a project from Brazil?
Yeah, so maybe you mean this open data thing here for Elasticsearch here? Yeah, maybe they should. They should in all cases, but they don't do. So maybe because they don't have to, yeah, and maybe they're not interested in the citizens. That's the point. Yeah. And I would say this is the wrong approach. So the good approach would be to involve citizens, because we are in need of more data. We are in need of more data in all environmental fields, and we want the citizens to be able to work with the data, to understand how the data is created or how an index is created. We want them to understand, and this is an approach, the citizen science approach, to involve people in these questions very early on. And citizen science as an approach is a very old approach. Yeah, it's
sorry. Basically, that question was about that unstructured open data, but I think you have JSON data, right? Those the data you were showing.
You mean in the Sensor Things, it's JSON data. Here it's an FTP server with at the end CSV files if you find them, but it's kind of difficult to understand which weather station is meant for which data. I didn't want to dig very deep. It was just an example to show you how horrible open data can be if someone don't want people really to work with this data. This is why I don't want to elaborate too deep on the technologies they use to do that.
Yeah, it was just a question from one of our teachers, my colleague Frederick. So he wanted to just know your views.
Yeah. Okay, so back on track. So citizen science as one approach that I think would fit better here. It's an old approach. So you see also on this on the edge of the picture, people looking up to the air. They are watching birds. Yeah, so this kind of bird counts, they are there for more than 100 years. When researchers realized, okay, we are not able to be everywhere to observe birds and count birds to find out more about diversity in our country, for example. So they started to involve hobby scientists, at that time, people to do that and to hand in their observations on paper, basically. And then all the researchers used these observations on paper and then understood better about which birds are where at which time, basically. And there were these activities like as the Christmas bird count, or in Germany we have the Stunde der Wintervögel, Stunde der Gartenvögel, which is 1 hour of winter birds, where people are observing birds on the same weekend in the year for 1 hour, and a lot of people are doing that. Some 100,000 people participate. In the last year, I think it was close to, in the Corona year, it was close to 200,000 people that participated in this activity here. And of course, nowadays, 100 years back, and also probably 20 years back or 30 years back, it was paper as the main medium to transport the data. But now, of course, there is an app which helps you also to identify the birds and then to submit your observations, basically. Yeah, so this is one approach from citizen science, but there are plenty of other citizen science projects, and also to show how important and how successful citizen science as an approach can be. This example here, which went around the world in plenty of newspapers here from the New York Times, the German amateurs who discovered insect Armageddon. So there was a club, the Entomological Society in Krefeld, which are private people that were working for 30 years, and they were basically counting insects. Yeah, counting. In fact, they were counting the biomass of insects for 30 years. Yeah, and they realized, and in 2017 they published a paper together with other scientists, citizen scientists, with full-time scientists, basically, on the insect Armageddon, that the biomass has decreased by 60% within the last 30 years, which led to huge impact, which had a huge impact not only in science, but in politics and in the way in agriculture, and it changed a lot. Yeah, this work of a bunch of citizen scientists from a small city in Germany had massive impact, and the news went around the world as well. And these things are only possible when citizens are involved. So these are things that you could not do for 30 years with full-time scientists, that you would need a lot of people and a lot of money to do that.
Yeah.
And plenty of other projects you might have come across in the last years as well, like Galaxy Zoos, where citizens had to classify galaxies. Old Weather, where citizens had to interpret the writings of captains of old vessels and ships, their logbooks, to find out about the weather in the oceans in the last hundreds of years, which helped to understand also and help to design better climate models, basically, because this is data we don't have. Yeah, we have weather data from the last 50 years, maybe from the last 100 years, but on the ships the data was collected, and especially in the seas already much longer time ago. So very interesting data came up here. And also we observed a few citizen science projects related to measurements. Yeah, there was the GLOBE program that started in the 90s. And here it was already very strongly linked to education, where students, high school students around the world, were installing weather stations and then also collecting the data and sending the data, and at times in an Excel file to a mail, and some other people were putting the data together. Yeah, maybe you know that. One of the first projects were sensors really used by the citizens are involved, and somewhat this Internet of Things approach came up the first time in citizen science was the Air Quality Egg. So this was a DIY project started 10 years ago, so 2011 more or less, 2012, where a designer from New York and an electrotechnical guy set up a device based on Arduino and a very, very bad air quality sensor, and created this website you see here, and then put an egg-like case around it, and the air quality egg was born. And I don't know, a few hundred or less than 100 of these eggs were distributed, and data was collected. And the data was complete bullshit. Yeah, it didn't work at all, but the idea and the functionality, which was done by two guys and pretty simple, was there, and it was interesting. And it was also, and this is what they said, it was not about the data itself, it was about making people think about air quality in general, and it helped. It worked out. So Muki Haklay, which is a scientist from UCL, he is working on citizen science for a long time. This is a graphic also 10 years old, yeah, and he said that there are plenty of levels of this citizen science, and we have seen now in the examples I've shown already different levels of citizen science involved. So of course the major, and this is why it's a pyramid here, mostly citizens are being used as sensors. It's this kind of crowdsourcing level 1, citizens as sensors, where they only collect data. But it's not the way we should go, because really to make people understand things and to involve them into a question and to make them really part of the science, we need and we want to go up there towards extreme citizen science. So a kind of collaborative science where citizens are involved in the problem definition, where they are involved in the data collection, in the analysis, and maybe as the guys in Krefeld in this Insect Armageddon, even in the publication. Yeah, this is a great way to go, and something really interesting. It's kind of
since you were talking about citizen science, there was a question that popped up about citizen science itself. So it's more about the idea of citizen science. So is citizen science a non-profit action, or can it be turned to some form of profit projects if we use some free open source API like OGC Sensor Things APIs?
Well, you would think that citizen science should be the involvement of citizens in such projects should be a non-profit thing. Of course, it would be strange. Maybe I can make a relation or a comparison to other crowdsourcing projects. Yeah, so if you think of other crowdsourcing ideas like Wikipedia, Wikipedia itself is a non-profit, and people contribute to Wikipedia. If you think about Openstreetmap, and I will have it as an example in a few seconds. Yeah, Openstreetmap people contribute with by mapping the world. Yeah, and it's non-profit, but one can use the map for anything. But also Google Maps also involves voluntary mappers all around the world. Yeah, people are making Google Maps better, and they do it for free. But Google makes a lot of money with this map. Yeah, so there is also a very different let's say way of contribution in the crowdsourcing area. And in terms of maybe the question towards the standards and things, well, one, of course, I think that citizen science should follow the open science approach. Yeah, so the data that comes out of citizen science projects should be open data, and the technologies that are being used should be open source. Yeah, open source software, open source hardware. And I know that it's not the case all the time. Yeah, so there are citizen science projects where full-time scientists are involved, that are afraid, as a lot of scientists are afraid of, to publish the data as open data, because they think, somebody will still steal my data and then publish something in advance, yeah, and maybe go ahead with the results or whatever. So, but I think that citizen science should be open science, should follow the open science approaches.
And since we are also talking about citizen science at this moment, let me grab a quick question also on citizen science. So should academia work towards informing and molding citizen science in how to collect data and handle data, rather than spending their time collecting data on their own?
Yeah, this is the point. It depends on the field. Yeah, I think in fields like biodiversity and fields like monitoring of the environment, this is possible. But also it depends on the approach. Yeah, it has a trade-off, of course. If you work with citizens, and if you want to involve a lot of sensors, and this is what we're going to see in a few minutes, they need to be cheap. Yeah, they need to be affordable. But affordable means also that they maybe lack in quality in comparison of a high quality weather station, for example, that is expensive. But still, there might be, and this is the interesting thing. There is still a gain of information that we can pull out of this. Maybe data, masses of data of a bit lower quality, but there are masses of data, and still it's very interesting data. Yeah, so I think that it's a good approach, and it fits to plenty of fields, but for sure not to all fields. Yeah, if we now think about medicine or virology, of course, it's not a good way to go if people if we start to involve people in the collection of data for virology, for example. Okay, coming back to this involvement of citizens and empowerment of citizens. Yeah, I also brought another tweet here, which makes it clear: citizens without data have an opinion. Yeah, citizens with data have evidence. So this is something that is only possible with open data. Yeah? So if you have the data, have access to the data, then you also have evidence with you, basically. But not having the data, you are maybe the little Trump just have an opinion that climate change is not there. Yeah, and here we go, data quality. What about the data quality? So and the lesson I would like to share from Openstreetmap. Yeah, Openstreetmap, if you know that, yeah, it's about creating this great world map, which is open in terms of the use of the map, but also the data behind it. So it's collecting spatial data on anything. You can map anything as a participant there. It's not citizen science because there is no scientific question behind that. It's a crowdsourcing project similar to Wikipedia, and it's plenty of data on anything you can imagine. Every tree, you can map every tree, every bench or whatever you find around the world. Out of this data, this map is generated, and not all data is in the map. This is also another issue. So you have much more data than is displayed on the map as well. And in OpenStreetMap, which was launched, it's close to 20 years right now. For a long time, this project OpenStreetMap was criticized by the authorities, and still is in part. So you will find authorities, mapping agencies, official state mapping agencies that said it's really bullshit. It's horrible data and whatever. But it was really the general words in the beginning of the project. Now OpenStreetMap got so much better. Throughout the years, the community has grown, and the community is correcting the data all the time. It's huge mass of people that is working on that, and much approach has changed how to make the data better by involving satellite and aerial imagery to correct data that was maybe collected via GPS and things like that. And it's got a really very relevant source for science. It is a very interesting topic of science, so there's plenty of publications on OpenStreetMap, on the data, on the contributions, and so on. It got very useful and powerful, especially also in regions that don't have own mapping agency around the world. So there are plenty of regions that where OpenStreetMap got the major map. And the main map being used in the country, so really important, and has a huge impact when you think about the humanitarian OpenStreetMap team that was launched, started 10 years ago after the huge earthquake in Haiti. So Haiti maps are in a perfect shape on OpenStreetMap due to this humanitarian OSM team, but all around the world they help in plenty of issues where no spatial data is available. So what I wanted to say with that, in OpenStreetMap at the beginning, the data quality in the first, let's say, 10 years was really low. Got better, but it was low and not very much accepted by the authorities. And this is the place where we are right now with data from citizens using sensors, low quality sensors. So we are in the beginning. We started 10 years ago, as I mentioned, was the first project with sensors and citizens, which was the Air Quality Act. And it was horrible data, and we are now 10 years ahead, and we are much further, but still not around that everybody would say, wow, this is perfect data right now. So we are on the way, and we would like to learn from volunteer geographic information, VGI, which is here in the title of this slide, like in Openstreetmap. Yeah, and this is where we come to SenseBox. So I'm half through, more than half through now, and coming to the tool. Yeah, we have developed in Münster. So this is something we were following 10 years ago, the air quality, and this times in our educational initiatives in the lab, in the GI School lab, we thought, oh, this would be great to have a device, an IoT device connecting a lot of sensors to microcontrollers, but make it easy for everybody to set it up, to build it, to program it, to code it, and make it completely open source. And this is where the ideas for SenseBox came up. So we created throughout the years, and the first ideas are more or less 10 years ago, and throughout the years we created several kinds of devices based on the same hardware. Yeah, and we focus on Arduino as the hardware platform. Yeah, at the beginning, we made this decision. We started with Arduino and created devices for the use at home, basically the SenseBox Home, which would be the device you use as a citizen scientist. You set up a weather station, environmental weather station or environmental station, and you connect it to the internet. And then we had this device for education, which are the same things, but a bit different in this green box on the right side, which can be used in schools, in museums, or in other educational institutions. And then afterwards, we designed even a smaller version, the SenseBox Mini, which has fewer parts, just for, let's say, starters and in this area. But after working with Arduino as the key microcontroller, we started with Arduino Uno, which is a very simple one. We designed, around 4 years ago, we designed an own microcontroller based on Arduino. So it's basically Arduino at heart. It has an Arduino processor that works with Arduino. It's an SAMD processor, a microchip on it. And we took all this experience from the first, let's say, 5 years working with high school students, working with citizens in citizen science context, to build up this pretty special microcontroller. It's some kind of a microcontroller that can do a lot of things. So it is very flexible. It has these connectors, the white connectors on it for I2C, UART, digital analog input outputs on it. Yeah, so it has connectors. So you don't have to start with soldering wires or whatever, yeah, as you have to do with some other systems as well. We have these modules. You see these black lines on the right lower side here, where you can put different kind of modules with following the XP standard to enhance the controller with very different data transmission possibilities. Yeah, I will come back to that later. And yeah, there are plenty of LEDs on it, buttons, and one sensor is already on board, which is the BMX sensor, which is an acceleration sensor and compass sensor. So you can do plenty of experiments with the board, but basically you know how the board is situated in the world, basically, yeah, which is interesting for different applications. So these data modules that come on this XP standard, you can put it in. So we have 4 already launched, and 2 will be launched in a few weeks. Which is Ethernet Wi-Fi is there. We have one with an SD card. So if you want to create data loggers, you can just put such kind of a SDB on it. And we have one using LoRa. So I have also seen that you learned a bit already about LoRa as a transmission way to transmit data on a special bandwidth, and we use this LoRa in different applications. Usually, people using that with a SenseBox connect to the so-called the Things network. I don't know if you know about that already. Yeah, it seems like so. You can use it for free, basically, by sending some packages of data every few minutes. Yeah, and it's a great way to do that. And in a lot of countries, LoRa is really exploding currently as a possibility to connect to the internet. And we have in a few weeks, as I said, we will also have the Bluetooth and the GSM be ready. So GSM with an integrated SIM card and Bluetooth to make a simple, quick connection to smartphones or whatever. And then sensors, yeah, we are in the Arduino world, so you can add any kind of sensor to this board that works with Arduino, and we prepared in our libraries already sensors and cell sensors for different things already. So temperature, humidity, air pressure, brightness, UV intensity, volatile gases, organic gases, basically components, fine dust sensors, sound level, wind speed, humidity of soil. And so there are plenty of sensors. CO2, I didn't mention that on the slide here, but I see the sensor in the picture as well. So different things, and we worked for a few years on. We don't invent sensors. We are the geoinformatics people, so we work on the code, yeah, but not on the sensor themselves. So we investigated good sensors for a reasonable price, basically. Yeah. So being in the citizen science range, we want to have a device at the end that is affordable for citizens. Yeah, and so it's impossible for us to work to have sensors that cost a few €1,000s. So every sensor here costs less than €100 and much less than €100, yeah, depending on the sensor. But still, if you are in this world, you can get temperature sensors for less than $1. Yeah, our temperature sensors are more or less $5 to $10. So still, they are good sensors.
So for many different sensors, you are writing your own libraries, or sometimes you are making those libraries public. So what's the solution here?
Usually we use the libraries of the sensor suppliers. So there are sensors from different suppliers here that we involve in our system, and depending on the sensor and the library how it works, we also write our own libraries. Yeah, but usually we refer to the libraries of the suppliers as well.
And then people who are having your, let's say, SenseBox Mini or SenseBox Home, you are providing them the libraries as, like, if they want to extend the libraries.
Yes.
Or the product.
Yes, everything we do is open source. So everything is open source, and if the libraries also of the suppliers are available, so we also publish or link them, and everything we do is open source. Everything.
Mm-hmm. So right now, people say if they don't want to have your SenseBox Mini, but they want to, let's say, use one of the sensor libraries, are they allowed to, or?
Yes, of course.
Mm-hmm.
Yeah,
that's an interesting contribution also to the citizen science, I think.
Yeah, and there is plenty of other stuff that has been created in the last years. This pretty new solar charger here that also works as a sensor in terms of the capacity of the battery, that you can also read out and put it somewhere, send it somewhere to the internet. Solar chargers, expanders to add more sensors, multiplexers, so to even use the same with the same sensors and the same connectors, basically. A real-time clock for the if you want to save data on the SD card, for example, in a data logger, then and you don't have a GPS with you, so it's interesting to have the real-time clock. But here, coming back to the sensors, we have also a GPS sensor, basically a GPS receiver that you can use also for mobile applications as well.
So there was also a question about, since you were talking about sensors, about carbon dioxide concentration. So do you have any kind of sensors that measure carbon dioxide concentration in the air, or?
Yes. So there is the sensor which is on the bottom right here. This is the Sensirion SDC30, which is from a Swiss company. Sensirion is a really good Swiss company, and it's a CO2 sensor. But and here we go. There are no good sensors for carbon dioxide concentration in this price range that you could use in the free air. Yeah. So we speak here on the price range of €50, more or less, €56 for such a sensor, and it works indoor. Yeah, so it's still, and we are mainly in the outdoor world, so in the environment, but still some applications are very interesting indoors. Yeah, if we speak about air quality, we spend most of our life indoors. Yeah, so usually at least here in this area. So indoor air quality is a very interesting field also in health. And here, for example, the CO2 sensor we have. Is being used heavily currently, especially in the COVID. Since the COVID crisis, it gives you a great idea when to open the window, when to let in fresh air. But if you use this sensor and want to see the differences of carbon dioxide concentration in the forest and next to a highway, you won't find differences. Yeah. In this price range, it's impossible.
So you're talking about here the data quality again.
Yeah, let's not. I wouldn't say it's not a data quality issue. It's the sensor. Especially it's really very dependent on the phenomenon. Yeah, it's carbon dioxide concentration is it's a phenomenon that spreads in the atmosphere very equally, very fast. Yeah. So we have the information we have about the change of the carbon dioxide concentration is a global problem. Yeah. It's not a local problem. While, for example, fine dust is extremely local, or sound level, the loudness is an extremely local thing. Yeah. So if you measure the sound level at one spot, you will have in space and time, you have huge differences. Yeah, while in carbon dioxide, you won't have nearly any differences. If you change the place for 100 meters, there's no difference. Yeah, so it's really extremely dependent on the phenomenon you are measuring, and which questions you want to solve, which questions you have basically, and what you want later on, what you want to do with the data. So carbon dioxide concentration is an indoor thing in our world, in the citizen science world, while sound or dust, fine dust, maybe in the environment.
No, basically, when I was talking about data quality, I meant how good your sensors are. So, are the readings accurate enough or good enough to be used in real life applications, or how sensitive your data are?
Yes, so here again, it's always an issue. As I said, we evaluated the sensors for some time. They are very good sensors, but here again, working with citizens means you never know what they do, how they set up the sensor, the device, if they put it, even if you have an instruction with it, if they put it the right way, if they put it in the full sun, or what they do. So these are very interesting and open questions, yeah, to work with instructions and then to try to get the most out of the data that comes with the sensor. Yeah, one very good example is the temperature sensor. So the WMO standard for temperature measurements speaks about a case, which is this housing of the sensor, which is a classical wooden. I'm going to switch back to one of I remember the globe slide had it on it. Yeah, something like that. This white housing having a weather station, the temperature sensor of the weather station in it. Yeah, the standard, the WMO standard speaks of a even larger housing. Yeah, it's a big wooden box painted in white. We sell that. We make that. There is a carpenter doing that. Yeah, and if you sell that, only the case for the sensor. It's handmade, yeah. It's 500 euros. Yeah. The sensor itself, it's in the lab quality. It's of highest quality. It's only 5 euros. Yeah. And the case is 500 euros. Yeah. So this is one way to do it, and it makes a huge data quality difference here. And we, for example, to meet the citizen science approach, and now I'm coming to the other stuff back here. On the right side, you see a plastic case for our temperature sensor, where the cost is 10 euros. And of course, it's much worse. The data is much worse with this case as with the 500 euro wooden handmade case and painted in white. Yeah. But still, this is better than nothing, Yeah. So if you know about the case, and if you have the metadata about how the measurement has been made, you still have more information that no information. Yeah. So this is the approach here. Okay, so going on here, so DIY, if you put all these components or the ones you have chosen for your question, you can put them together, yeah, so screw it together and you maybe have this kind of device here. This could be the SenseBox for air quality measurement or fine dust and temperature, humidity, and light phenomena, for example. Yeah, and you can put it somewhere. So this is one we have as a reference station on next to a official, whether we have a few of our sense boxes really directly next to the authorities, very professional, very expensive weather stations as benchmarks. Yeah, so this is one, for example. You connect it to the internet through LoRa or Wi-Fi or whatever you would like, and then you have the data. Yeah, and the data goes to our OpenSenseMap. This was from the beginning of the SenseBox idea. We thought having an IoT context here, having a platform where the data goes to. Yeah. So this was the hardware itself, and then having a platform. And here, as the name suggests, we followed a bit the idea of Openstreetmap as well. But having a platform which is open for any kind of environmental measurements. Yeah. So currently there are more than 8,200 stations registered on the OpenSenseMap, and maybe to make it clearer, I'm gonna I got it. I'm gonna show you the website. So this is the OpenSenseMap currently. So we have 8,295 sense boxes registered there, and it's close to 9 billion measurements that we have collected. Yeah, and if you go on one of the sense boxes, and this is the one in my garden here. So this one is a few meters away, and you see here, yeah, there is some weather happening here currently. So this is the temperature measurements currently. Air pressure, and I have dust, and I have wind as well. So there was some wind events a few minutes back, but right now it stands still. Yeah.
So since you were talking about wind here, so there was a related question also. You have a wind speed sensor in your kit.
Yeah.
So what makes a sensor reliable, and what's your experience in terms of reading?
In terms of wind speed?
Yeah.
Well, you have plenty of approaches to measure wind speed. So we work with this kind of, I right now have only the German word for it. This spinning device up there, taking the air, taking it, and then you measure the times that it turns, basically, with a magnetic sensor in there. Yeah? And you have also other ultrasonic ways to measure wind speed with ultrasonic devices. There are plenty of ways. And also here, we have to, if we are in citizen science, we have to go through the price. We can't take the best sensors that are available because we work with citizens. Yeah. And here again, you can buy such kind of sensors for a few euros, for 50 to 100 euros, which is our price range, and for several hundred euros, which would be too much for citizens. Yeah. So this is our way to do it. Yeah. We go through a good meeting of price and quality of the sensor. But basically, and this is it, the SenseBox is open in terms of you can add any sensor. You can also add very shitty sensors to the SenseBox. Yeah, it's open. Yeah, it's Arduino, so you can create your own device and register it on the OpenSenseMap. And out of these over 8,000 devices registered, there are plenty of DIY devices of whatever people did. Yeah. And here again, we want to go the long way. We want to go the long way. This is more the vision of OpenSenseMap. Also with the following also the lessons we've learned from OpenStreetMap. Yeah, at the beginning, anybody could map anything, and still anybody could map anything. But the data got better and better throughout the time, and this is the way we want to go. And I will show you some other ideas where we're going to work on data quality. Yeah, but coming back to the front end here of OpenSenseMap, so this is our front end, the current front end. You can dig through the data. You can check the graphs here for the measurements. This is always the last 48 hours. You can check for the last week or last month or whatever. You can make data downloads through this interface here. So you select the one sense box or several boxes and select the sensors and try and get the downloads in the CSV file. You can filter, you can do some interpolations here. I don't want to show that right now. But this is only the front end, you know. And one important thing, I'm going to go back here. One important thing here, one major thing on this platform, on our OpenSenseMap, is that any other platform has in this open data and citizen science approach, our API, which comes with this platform, of course, allows you to access all historic data all the time, which makes also the platform kind of expensive. Yeah, it is. We have all the data available in the database, and the server is ready to get your request for seeing the data from New Year's Eve 2016 from one station in Berlin, and you can get it just right now. And this is something that this kind of platforms usually don't offer, because it's pretty expensive to do that. Yeah. To have this capability ready to go. Having 9 billion measurements in the database, yeah.
And you also allow data sharing, like if I want to see temperature data from other sense boxes from other locations.
Yes, everything is open data. So everything when you connect a device with the OpenSenseMap, the data that is transmitted to the OpenSenseMap is open data. Everybody can see and download all data on OpenSenseMap. So right now, this interface looks like that already for some time, and I'm right now searching my mouse. I'm sorry. It's strange. Okay. Can't find my mouse. Okay, so on data.opensensemap.org, there is a new beta version of the OpenSenseMap, allowing a lot of other things to do with the data directly in the front end. And we are working on that, and we'll launch it in a few weeks. But it's already accessible, so if you want to have a look, data.opensensemap.org brings a lot of new things, cartographic functionalities to the interface as well, possibilities to compare sense boxes, to authority stations, and so on and so on. So it brings plenty of new functionalities. I'm going to try again. I'm not sure why I can't find my mouse. It's somewhat disappeared.
Yeah, we can see your mouse.
You can see my mouse. Yeah, I see it also in the recording, but I can't see it in my. This is really strange. Yeah. Okay. So data.opensensemap. Yeah, I'm going to show it. This is strange. I have not seen that yet. Okay. So here it's a little bit different how we look at the data. So you see here in the bottom, you see the phenomena, for example, PM10 of one device. Now I can click on a different device here and compare it to the one I have selected before. I decided on one to. Yeah. As I don't see my mouse currently, it's kind of difficult to find one that is available. Okay, yeah, but you can compare things. You have seen the little graph in the beginning, and there are possibilities to compare the stations and each sensor with each other, and so on. There will be a lot of functionalities added to this system in the future. Here we are working in a research project also to add some kind of social network functionalities here. So the citizen scientists get more connected, can comment on their boxes, on their measurements, can start campaigns together and things like that. Also, something very unique for this kind of platforms is that we allow in our data model and also in the front end, we allow mobile measurements. So it's a platform where stationary measurements and mobile measurements are possible at the same time. So here you see one SenseBox was where a GPS was connected. So every measurement receives a GPS coordinate. Here, this one was submitting through LoRa as well in Berlin, and then you see measurements on the map also in this path visualization here. So this is something that usually this kind of platforms don't offer, and ours understands stationary and mobile sensors as well. This is an example of the interpolation, but it's only the functionalities of the front end, so this doesn't matter. So as I mentioned, plenty, so more than 8,000 devices, close to 9 billion measurements. And something interesting, which you won't find in other platforms this way as well. And this is something where I want to lead towards the topic of usability, is that we have around 60%, more than 60% of the registered devices on OpenSense are live, so sending live data, which is a really extremely high number. Usually in this citizen science project, people tend to use it and then leave it after a few days, a few weeks. So maybe you know a device from the Fab Lab of Barcelona, the Smart Citizen device. It's called Smart Citizen. If you check the website, it's really of great design, and the device is also of a great design. If you check on the numbers of the stations, well, it's not as high as with OpenSenseMap, but if you check on the numbers of live stations, they're in around 5% of their stations are live. People tend to use it and then they left it. So we are really proud of this it's really an extremely high level of citizens that stick to the project and stick to collect data here. Mm-hmm. Yeah, and to come back to usability, this is our data model. Yeah, it's extremely simplified. So we are from geoinformatics and working for a long time with the huge standards. The huge standards for observations and measurements. Having a 400 pages document, we started with a blank page and draw a data model which had at the beginning. This is the beginning. Yeah, we have changed it a little bit already, but we started with one page. We started again with a white page and redesigned the data model from the beginning, which is extremely simple. And of course, we have come across plenty of issues, and we are now, it's growing. The data model is growing. It's not one page anymore. It's maybe 3 pages currently, but it's still a very simple data model. And this is something important. If you want people at the end to understand your data, you need to really take care of that. And also here we have costs. Not having masses of metadata makes the data quality worse, but the data more understandable. So it's somewhat difficult path you have to go through usability and data quality. And it's the same with the hardware itself. So if you want to work with DIY systems, you want people to work with the hardware. Other people prefer to have a black box station that they don't need to touch. They just put it somewhere and it connects automatically to your Wi-Fi and whatever. But you can't check what kind of sensor is in there, and it's not very transparent, not very open. And we want to open up this black box.
Yeah, and also since you are talking about data and database, and you showed a fairly large number in your previous slide, so there was a question about your like how you handle those large data. Are you storing your data in a centralized database or in a distributed database, or?
It's a centralized database. I'm going to come back to the technological in a few slides. It's a centralized MongoDB database, and I'm going to come back to that. So the heart behind it, it's the API, the OpenSensive API, which is pretty well documented and gives you the understanding how to post measurements, how to get the measurements, and how to work with the data. So this is something we currently still work on, and it's great to see. And also if we see the publications around the world using OpenSensive also for science, it's really growing. So it's really great to see that our approach somewhat is being accepted by the community as well, and especially being that open. Usually plenty of these kind of platforms are not as open as you might believe. Yeah, they are not open for all kinds of devices. This one is. Yeah, this is the link to the API. If you want to check that, this is the way to go. Yeah, this is the question to the architecture. So we have 3 MongoDB instances connected to each other, where it's a centralized system where the data goes to, and of course, and we are working and still investigating, or currently investigating, also other approaches of storing the data in time series databases that might be faster in the data access in different questions. But as we have very well the approach with spatial data, so we have data where we want to apply questions, for example, like interpolations or other operations that take the space into account. In these questions, the time series databases that are very good and very fast for one phenomenon and one sensor over time, yeah, they get more complicated if you take space into the account. So that's why we're still looking for alternatives, but currently we are fine with the MongoDB approach here. Yeah, everything runs in a Docker container. So if you check our GitHub, you can just get the Docker container and install an OpenSenseMap instance on your device as well. So plenty of people do that, and we have, for example, for a completely different citizen science project from JRC, from the European Commission, and they use OpenSenseMap for the alien species project, yeah, to map alien species in Europe. So they're the sensors. Sensor is a camera and an app that submits pictures of alien species, yeah, and it's using the same architecture. Yeah, as I mentioned, and I mentioned already plenty of times, open is the key here. So we follow the open science approach. Everything you have seen and will see is open source. It's the SenseBox is open source hardware. Our code is open source software. You can add any kinds of sensors to SenseBox or any kind of devices on OpenSenseMap. It's open in a different way. So other devices like this one here from a citizen science project only on air quality is using our platform. The Chaos Computer Club was using our platform for different things. And also the thing, what kind of sensors are being used for water, whatever. Yeah, if you check on the OpenSenseMap and the sensors, the phenomena that are being mapped, it's everything in there. Yeah, so there are people having swimming pools operated and used by that. There are people in the smart home context that are using the OpenSenseMap as a platform to steer different devices in your home and so on. As the API is open, people started to create their own interfaces. So this was a design agency from Lisbon that created a nice visualization of their SenseBox. It's an open API, so you can just access the data and display it however you like to. Yeah. Or the scientist here that created an R package that is connecting to it's an R API for the SenseBox, so you can directly get data through R from the OpenSense. This example is already a few years back, but he accessed at that time all SenseBoxes that delivered air quality data, and showed this high rise of fine dust on New Year's Eve. Yeah.
So this R API is for importing your data, or?
Yes, exactly. Yeah.
Okay.
Yeah, I'm going to skip that because usability of the hardware. Yeah, I'm going to skip that. Time is running. Yeah, another thing I would like to speak about quickly, and this is related to data quality, because this question comes up, of course, often. So we created an ontology to link our database basically to other ontologies, other databases, speaking about phenomena, sensors, and domains we are working in. And the problem where it came from, when we started to create the OpenSenseMap a few years back, we wanted to be as open as OpenStreetMap. So in OpenStreetMap, everybody can map anything. and you can just invent a new triple, and you can map, I don't know, leaves on the ground if you want to, and really put them in the database. And this is something we also wanted to do, and so we left it open to name the phenomenon you are mapping, you want to measure with your sensor. And this created a huge problem. So what you see here is a screenshot, and you see on the right side our filter on the OpenSenseMap and on the phenomena, and you see temperature. And you don't see everything because there are like currently 70 or 80 phenomena that have temp in the name of the phenomenon. So people make typos. Yeah, they write it in different languages. They call the phenomenon temperature and put the name of the sensor behind it in brackets. They put the place behind it. So if people are having temperature sensors in their flat and have one in the living room and one in the sleeping room and whatever, and they create a phenomenon called temperature living room, temperature sleeping room. Yeah. So we have this massive amount of phenomena in the database, which makes it difficult later on to really analyze all temperature data outdoor, for example. And so we are right now putting in the new website that you have seen, the data.opensensemap on opensensemap.org, putting in an ontology which will link to a web application, our sensor wiki, that's how we called it. It's the sensor ontology web application. And here you really have to add the phenomena into this application first. You have to add sensors that can measure this phenomena into this application first, and then the OpenSenseMap will get this phenomena out there. So in the future, there will only be one temperature phenomenon. There can't be 5 or 7 temperature phenomena. There's only one temperature or air temperature phenomenon. Of course, there will be a water temperature phenomenon and so on. And in this wiki, we have also roles for experts that then can assign phenomena sensors as correct or as good sensors or bad sensors. So later on in OpenSenseMap, you can also then filter through, for example, valid phenomena, yeah, and not fantasy phenomena or whatever. Because of course it's an open source crowdsourcing tool, so you can also create fantasy phenomena in there. But then they won't be approved by the experts. Yeah, they will be there in the database, but you can filter them basically if you don't want them. So it's another level of crowdsourcing here. So we are crowdsourcing an ontology that will be applied to the huge OpenSenseMap database. And if anybody comes up with a new idea for radioactivity, so anybody can add radioactivity as a new phenomenon and add a new sensor that is right now on the market for radioactivity to this wiki, and then it will be available to choose from in OpenSenseMap. So this is our solution also to make the data quality better here.
And also, like I had a quick question. So how did you validate this ontology? Like when there is something new coming up and someone is making a new entry to the ontology, how do you make sure that it's valid in the context of ontology?
Yeah, so for the ontology itself, we created the ontology with its classes, as you see it here. So this is already valid itself. So we follow and we linked it to many other ontologies, for example, for units. Yeah, we don't want people to invent new units because they are ready to go ontologies that have all units that are there. And if a new unit comes in, so the other ontology has the new unit and brings it with it. Yeah. If anybody is adding a new phenomenon, yeah, then what we can do is everybody can also import a fantasy phenomenon in here. But we want, and this is what you see here in this example on the right side, it's a bit small. Here, this verification thing. Yeah. So we will have and have experts on phenomena and on sensors as well that can verify if a sensor, for example, is good or bad, or if the phenomenon is a real phenomenon, a physical phenomenon or not. Yeah. Yeah. So this is the last slide here on the issue here, and just to make it quick because time is really
No,
running.
we have
Right now.
enough time. I mean, if you need more time, we can get some.
Yeah, just a few minutes because I also wanted to speak on about education, and this is where the ideas for the project came from education. So we were working with high school kids, and we thought of this toolkit that has grown extremely towards citizen science and so on, but still the device that you have seen can be put together in another way and be really an interesting device for education, for digital education, basically. So the SenseBox Edu, as I mentioned in the beginning, it has the same controller you see here in this green box, but it's put together in such kind of a box that can really be easily used in schools, universities, and so on. So this is something that is being used in plenty of primary schools, high schools, but also in higher education in universities, and also in other forms of education. So plenty of museums are using that for workshops or whatever. And you have this big box where plenty of the small boxes go into. And a class of high school students, for example, takes the box, create their own measurement device following their research question, take the measurements, maybe submit them to the SenseMap, and then put it all together back, and the next class can use it. Yeah, so it's interesting in schools for learning how to code, learning, but also learning to collect data, learning about data. So the context of data literacy is important here as well. Yeah. And so we have plenty of things already in the box. So it's a collection with plenty of these sensors and many more. You also, as you've seen here, there is this breadboard here. So if you want to, and that's the flexibility I mentioned early in the beginning of the talk, if you want to, of course, you can go and start wiring circuits. Yeah? So you don't have to because you have the connectors on the board. But in this educational kits, we know that, for example, in physics classes, wiring a circuit is of high interest, and that's why we allow it, and it's possible. So it's about this flexibility we wanted to offer to be able to use this device in all kinds of STEM disciplines. So in physics, for example, you might be interested in really wiring your circuit and maybe measuring something and then putting an LED on because of a high temperature or whatever, while in computer science classes or in biology, you're only interested in the measurement that is being displayed on a display, but not in the programming, but not really in the wiring in the circuit. Yeah. So it's this flexibility we want to bring to be applicable for, if you have really few time in the lessons, 30 minutes, you don't do the wiring. If you have plenty of time, you might want to do the wiring and learn other things. Yeah. We created a visual programming interface based on Blockly, which is an open source, let's say, open source tool for visual programming, and we have added everything that is in the SenseBox with own blocks. So I'm gonna show it also in the browser as well. If I find my mouse again through the video screen, okay, Blockly. So here you go. I'm going to leave it in the German version, but you can switch to English if you go there. Yeah, blockly.sensebox.de. What you do here is, maybe I'm going to zoom in a little bit. Yeah, this works. So you have all the sensors that are with the SenseBox in here. So this is the temperature, UV, the accelerometer, the dust sensor, air pressure, CO2, GPS, the GPS module, and so on. You have the connections to Wi-Fi, for example, to Bluetooth, for example, with our new Bluetooth device, to LoRa. So you create the LoRa messages here. You can use different ways how to transfer the messages through Cayenne or the Things network. Mm-hmm. We have the OpenSenseMap represented here. Yeah, so you can connect to the OpenSenseMap. You put in the IDs of the SenseBox and the access token for security. So not everybody can add to any SenseBox. Only your SenseBox. You only have access to your SenseBox that you have registered on OpenSenseMap here. And then say, for example, send measurement to OpenSenseMap with this sensor ID, and then for example, the temperature. Yeah. And on the right side, you see the Arduino code popping up. And if you're ready, you can transfer that to the SenseBox, and gets the code and it works. Yeah? And if you have the hardware assembled correctly, if the Wi-Fi B is on the XB slot and the sensor is connected, then it submits the data to the OpenSenseMap.
Interesting. Yes.
So this is the simplest way to do that. So we work with that, or not only we did that in the research, but we know that primary schools. So we speak about kids that read. You need to read because it's there are letters in here. Yeah, but third graders can program their own IoT hardware with this tool here, and do that. Yeah, we know of plenty primary school projects using that. Of course, you start with the simple things like the display that is included, and you at the display here, you show on the display, for example, show me the numbers of the temperature on the display. Yeah, this would be hello world without the OpenSenseMap part. Yeah, this is the hello world for SenseBox. I'm going to show it in a few seconds in an example of our live SenseBox here. But yeah, that's basically the programming. And we did that with plenty of in the research with plenty of schools and primary and high school students, and right now it's in use in hundreds, if not in thousands of educational institutions, mainly in Germany, but also in other countries as well. As we still are funded by the German Ministry of Education and Research, that's why, let's say, the marketing itself is somewhat central in Germany, but plenty of other countries are also importing the SenseBox. And also here open in terms of the open education resources. So we have plenty of materials that are ready to go, ready to use in high schools, in primary schools, or in higher education. And we ask if we know that, for example, another university, the ETH Zurich, is using the SenseBox in 3 fields of study. So in geomatics, in computer science, and in environmental engineering. In the bachelor courses, they use the SenseBox and OpenSenseMap. And they have also opened up their materials as open education resources, and they are available for download on the SenseBox website. Yeah, I'm going to skip the last few things here. So interdisciplinarity in terms of the subjects, computer science, geography, mathematics, other sciences like chemistry, physics, and so on. So this is where the SenseBox is being used in education. But also another way of transdisciplinarity I like to show is this literacy approach here. So with the SenseBox, we somewhat overlap scientific literacy in terms of, well, you can really do the whole scientific process with the SenseBox. From your question, you have a question, for example, on climate change or any other environmental issue. You build your own measurement device. You program your own measurement device. You can collect the data. You can access the data because you publish the data on OpenSenseMap. You can access the data. You can even analyze it through the OpenSenseMap and the API if you want to. And at the end, you publish the data. If you want, you can make the publication. But still, the whole process, scientific process, is applied here. But also the other literacies like computational literacy, this algorithmical thinking that you learn while programming the SenseBox, while building the device. And in the geoinformatics world, it's spatial literacy, which makes you understand, okay, if I do the measurements on this spot and my mate is doing the measurements on another spot, then we understand all the changes of the environment in space. Yeah, so this is an important issue. You think of, for example, climate phenomena in cities, or the difference between rural and city areas and so on. This is really special here. And at the end, which is missing here, is data literacy, of course. Yeah, if you create data, you work with the data. Of course, data literacy is another circle you would like to add here, maybe. Okay, so this would be it. Maybe one last slide to show you about how the story evolved from SenseBox. So what we have done at the University of Münster, we had SenseBox as a research project for a few years already. Now it's in the second phase, funded by the German Ministry of Education and Research. And 3 years back, as I mentioned in the beginning, we funded a spin-off company, Redo. Redo stands for Reengineering Education. That is the company that sells the SenseBox as a tool currently. So, and before you ask, it's still, everything is open source we do, but still there are companies focusing on open source business models, and that's what we do at Redo. But we left the OpenSenseMap as an open platform in the university. And currently, like a month ago, we funded OpenSenseLab as a non-profit company that will take over the OpenSenseMap, because of course, such kind of a platform can't live forever in the university. Yeah, the universities do not have the capacities to do that, to pay for that for forever. And that's why we looked and created a structure where the platform goes to, and this is this non-profit company called OpenSenseLab. The OpenSenseLab will host the OpenSenseMap. And it's also another thing that we've seen how Openstreetmap evolved. Openstreetmap had its servers at UCL, at University College of London, and then melted into a foundation. In our case, it's not a foundation. This is somewhat difficult in Germany. It's a non-profit organization that we have created here. But still, a contribution of University of Münster is that we are right now using the cloud services of the university to host all the data, which makes it possible to make all these services available for free currently. So we also offer well, everything you have seen for free completely, and this is pretty unique on this level. Yeah, one link I have here on this slide is a live SenseBox. So what we have done in the last days is creating a remote SenseBox. So this is a SenseBox which is set up in my office, and I'm at home. And you see a Twitch channel. There is a Raspberry Pi with a camera looking at this device here. And what I'm going to just show you with one little example is our programming here. So this is a little bit simplified Blockly interface here, where I'm going to switch to English now so you can follow what I'm going to do. English. Okay, so I'm going to send something to the SenseBox. The code I'm writing right now here at home, I'm going to send it to the SenseBox in my office. Yeah, print on display. I had that already. Sorry. Initialize the display. Show text number, and let's do a very simple thing. Let's try. I hope it works.
So this device is reading the code from the cloud?
Exactly, yeah. It takes a second. Let me just try once again. I don't know if it worked out, because it says nothing in the queue. Yeah. Well, maybe I have some kind of technical issue here. It's not showing my code. I tested it before we got into this here, but maybe there is an issue. I'm going to just quickly give another try for a second. Maybe if we have this issue, I can show it, but let's see how warm it is in the office now. I'm going to add the temperature here. It seems that we have an issue. I'm so sorry. I tested it beforehand, and we used it in plenty of workshops now in the Corona times to do it remotely, basically, when we couldn't meet other people.
Is the device sleeping, or I don't know, maybe?
Yeah, I'm not sure. No, it seems to be that my not submitted here, my Arduino sketch currently. I'm going to check what went wrong. Sorry for this live test. It's always the issue of a live demo. I should have pre-recorded that. Yeah. It's also a pretty uncommon way. Usually you have your hardware with you and you submit the code to your hardware, and not that the hardware is somewhere else. Yeah. Okay. Yeah. Let's see. Maybe it comes there in a few seconds, but I have my final slide, which is citizen science. And this is what I wanted to tell you guys here. Citizen science, in our approach, in the SenseBox approach, citizen science is our tool, method, and accelerator for digital learning. Yeah, so digital education, kids and youth and people and citizens are really that are maybe not that interested in digital STEM education and learning to code or whatever, can be interested to do that through the citizen science approach, through the environmental monitoring questions they have. So people that are interested in that learn to code easily. But it's the other way around as well. So digital learning can be a tool, a method, an accelerator for citizen science. Yeah, if people start to learn to code, to build their own devices, to understand how to get access to data, to create data, to download data and do data analysis, they get citizen scientists, by monitoring the environment, by collecting data, sharing the data, and opening up the data. So these two things help each other basically, and this is very special in our SenseBox approach here. And this is how I'm going to end my talk. And thank you very much. And I'm also still available and open for questions.
Yeah, thank you, Thomas, for this nice and interesting talk. And I agree with you that, this digital education and citizen science, they are complementary to each other. So there is no way that you leave one behind. We have a few questions also, but I think I already covered most of them. But I will just reiterate some of the questions that I left. So looking at the citizen science, it looks like using lots of citizens and usually one or two measurement devices. But I feel IoT will be far more devices, like millions or billions, and most of those are disconnected from a citizen. So the question here is, will the citizen science evolve to be citizen plus thing, or will there be a parallel ecosystem for the IoT things?
It's a good question. Yeah, it's a good question. So in our approach, the citizen is of high interest, because we don't want only the data. If you're really interested in only the data, and if you think that and if you want to, for example, make better science because you can collect more data, and there is this technology, and we know that there is this technology to spread plenty of sensors all around the world that have they are supplied by energy, whatever, solar or a good battery for a long time, and they can submit the data to the internet, then it's fine. And it works, and it will be possible without the citizens. Our approach is different, because we have two aims. We aim on more data, and we aim on educating and involving. It's more than using, it's involving the citizens, because we believe that only if the citizens really understand the process of how the data is generated and where the data comes from and what to do with the data, they will change their habits. And they won't change their habits, for example, if we speak about climate change, for example, if there is only data and scientists do all the work with the data. If you don't involve the citizens, I think it's better to involve the citizens. That's what I want to say.
Yes.
The other way is possible, but it's not our approach.
But it should be, yes. So there was another quick questions also on the cost of your educational box, like citizen SenseBox education. What's the general pricing of this kind of educational boxes?
So this educational, the SenseBox Edu costs around 250 euros, and it has 10 sensors included, sensors for 10 phenomena included, and wires and things like that. So, and LEDs and plenty of small stuff, actors, sensors, the controller itself, and the casing in terms of putting it all in this nice green box. And it's 250 euros. Yeah, and if you check, I think if you check on the SenseBox website, there is a link to the shop. You can find also the prices of the unique sensors and so on to understand more or less in which price ranges we are. But to give you the example, the SenseBox microcontroller, the MCU, costs around 35 euros, I think, which is quite a lot for a microcontroller. Yeah, we know how much ESP costs, a few bucks. Yeah. We also know how much an Arduino costs, and this is the point. So the SenseBox is produced completely in Germany, yeah, which puts some cost on it as well. So if we also in China, it would be much cheaper, of course. And it's kind of a special thing. Yeah, we put a lot of connectors on it. There are a few things that can't be done in a completely. It's machine made, but still, it's part of. Yeah, it's not completely machinable in terms of the high end production. Let's call it like that. That makes the price for the controller a little bit higher, but it brings still a lot of flexibility in terms of the educational and the citizen science use. Yeah. That's why we go this way.
And that programming platform, is it also free to use, or
it's free and open source and everything. Yeah. Even I didn't have enough time, but the programming platform, I showed just the programming. There is plenty of work in it. We are right now having a way to add tutorials to the platform. So there is one PhD student of mine who's working currently on a learning, to develop it further towards a learning platform with learning analytics approaches. Yeah, so there is already a tutorial creator where you add the tutorials and it automatically checks the code and it gives you feedback. It gives the learner feedback if, in terms of the computational thinking, you are good to go in understanding loops, for example, or variables or things, or general concepts of computer science, of programming, basically. And this is something that is being done currently in the PhD thesis, and the platform is still growing. And as well, the OpenSenseMap as a data platform is still growing in terms of the functionalities and the things that we want to do with it. As I mentioned in talk, adding, for example, social network functionalities to it. Yeah.
And also, people seems to be very interested in your talk. So, will it be possible also to share your lecture slides so that I can share with the students later?
Yes, of course. Yeah, I'm going to send you the slides right after that.
And there is also a nice question. I think it's a very good question for you. So, where would you see, or where you would like to see citizen science in 10 years, and where do you think it will be?
I would like to see citizen science as a method that is being applied in most of scientific fields, knowing that it's not possible in all kinds of scientific fields. Yeah, due to some ethical aspects, it's impossible, of course, to do that. But I miss it in a lot of fields currently where it would be possible. Yeah. And also going above the natural sciences and also to humanities and things like that, where there is plenty of potential for citizen science approaches that are not yet in use. So I think it will help science a lot, to get out of this some kind of ivory tower and the whole discussions. And we have seen I don't know about how it was in Sweden, but it was a huge thing in the last 1.5 years since COVID-19 came up. The trust in science had a huge discussion in the last 18 months in Germany, at least. Yeah, and I think citizen science in general in plenty of scientific fields would help to get more trust in science by making science more transparent, more accessible to the public, to everybody. Yeah.
And also, I think we did not mention one important aspect throughout this talk is the power. So how do you power your sense boxes?
Yeah, power. I didn't mention power. That's true. So the SenseBox, the MCU needs 5 volts. Yeah, so it's usually people power it if they have it at home, and there is possibility to have a power. There is power plug somewhere nearby. So it's a classical USB cable, currently USB-C cable that is connected.
Mm-hmm.
We have I mentioned on the slide with additional stuff. So we have a solar set as an additional toolkit there. So a solar panel and a solar charger, basically with batteries. So this is another way, and for that you can also, and this is how the device is made, you can start plenty of energy saving functionalities on the board. So you can disconnect any kind of circuits of the board if you want to save energy. You then code it in a different way. Currently, the standard coding of the SenseBox is taking measurements every minute, 1 minute per phenomenon, which is for some things interesting. For other things, it's not typical to do that. Yeah, for example, measuring temperature every minute is not really necessary. You can do that, but you don't have to do that. Yeah, because the change is much slower. So, but with special sensors, for example, the fine dust sensor uses a laser. So here, power is really an issue. If you really measure every minute and you send a laser beam once a minute, it's kind of a lot of energy consumption that you produce here. Same with the GPS, for example. So we offer plenty of energy saving functionalities to, for example, measure in smaller frequencies, to create data packages only, and then sending data packages once a while instead of sending every minute. Yeah, so there are plenty of ways to do that, and we have these functionalities, and we have these possibilities to code the SenseBox like that.
Yeah, I think that's also good to know. I mean, power is also a important factor if you're thinking about IoT solutions and running over the long time. And yes,
of course. But in general, I have to admit in these terms, the SenseBox was not made at the beginning, and as it is right now, it's not the typical device as you maybe have seen in the previous lectures on wireless sensor networks that you would put somewhere and with a small battery and it would work for years. Yeah, this is not the approach, and with the sensors we use, it would be difficult to do. Yeah, we would need to change a few things to be able to do that. But we know already, and we do that as well with a solar panel. It works fine. Yeah.
And that solar panel, does it comes with a package, or it's a
if you want to? Yeah, if you want to. No, you have to add it. But we have a solar panel in the shop and the charger additionally. And so if you want to and you don't have a power plug, or if you want to put it somewhere in the wild, then the solar panel would be a good way to do it.
Yes, yeah. So I think I don't have any more questions, but I tried to cover all of it. But there was one additional questions that I can stop after that one. So you are talking about always expenses and pricing factors for citizen science, but is there any, or in the future, is there any opportunity for this kind of projects subsidized by the municipalities or governments? And in Germany, what has been done until now?
Oh yes, it is, and it's not in the future. It's there already. So we love to see that. Maybe let me show one last quick way on my slide. So I will show you a project from a small city, and it's coming from a problem. So we have for example, air quality measurements and weather measurements. We have seen it on this map I have shown from the German Weather Service. Not every city has this weather station, and especially on air quality, there is the regulation of the European Union that in different cities of a different size, you need to install several of this kind of professional measurements. And then, as I mentioned, air quality is extremely local. So if you know the air quality of one city, the next city nearby can have a totally different air quality. Yeah? So especially smaller cities, let's say below 200,000 inhabitants, usually don't have this professional equipment, don't have this professional weather stations. So they started to work with citizens. Yeah? And one city, it has close to 100,000 inhabitants, south of Münster, recently started a project, and they invested and asked 100 inhabitants. The city is called Soest. 100 inhabitants to use the SenseBox, and they have bought the SenseBox. Yeah, so the city of Soest, you see it. It's called Bürgerwolke, which means in German citizen cloud. Yeah, that's the name of their project. Yeah, and they have bought 100 of these boxes. LoRa connected to LoRa. They have installed the LoRa gateways. So the city installed the LoRa gateways, and 100 inhabitants have their boxes. And we know of more cities doing that. Yeah, smaller cities tend to do that because they are don't have the equipment of the full of the professional devices. Yeah.
So it's more like crowdsourcing your IoT data or environmental.
Exactly. Yeah.
Yeah, it's good to know. I think that's it for today. And I want to thank you again, Dr. Thomas, for being with us. And hopefully we will receive you again next year if you agree. And we also look for some potential collaboration also between our university and your lab, and that would be also great.
Would be great.
And with this note, I would like to conclude this live session. And have a nice evening, everyone.
Thanks a lot. Bye-bye.